In the previous video, we're able to establish the standard form of a linear equation or a linear equation form of the first order differential equation. And it's actually in this form, right? We have the first order derivative of y with respect to x plus any function p of x times y be equal to our f of x. This is the standard form taken from the general first order differential equation form a sub 1 of x times your first order derivative of y with respect to x plus your a sub 0 of x times y be equal to g of x. So from this, we're able to come up with this standard form. Now, once we can establish this standard form, we are now going to provide the steps for solving this given equation. So this process is only true once we are sure that our given differential equation or the first order differential equation is a linear equation which can be transformed in this. So here are the steps in solving linear equation. The first one, okay, is of course finding the standard form. Okay, so standard form, because sometimes the equation or the first order differential equation in this form here is not yet a standard form, and if we are going to form it in this manner, it will not form into a linear equation. Hence, we can no longer proceed to the next step. We can only guarantee that we can use the next step once we can identify that it's really a linear equation. Second step, we are now going to solve or find an integrating factor. Okay, integrating factor expressed as mu of x. Okay, so this mu of x is actually has a certain process. Okay, we are going to actually use this to solve for our given linear equation, and we really need this because if we don't have this, we cannot solve the item, because it's actually in this manner. Once we can identify the integrating factor, we can actually construct our equation here in this form. You have your integrating factor mu of x times y is equal to the integral of your integrating factor mu of x f of x dx. Okay, this is actually equivalent to y, right? Okay, but since when we take its integration, these are just similar constants where we multiply on both sides, so we don't change the actual form. So basically, this is the use of our integrating factor. We will have a separate video for just the identification of integrating factors, so that we would know what to be used in our process as well. Now, after this, once you can guarantee this process where you can actually provide your integrating factor and y together with this side here, you just have to solve that in terms of y, because as soon as you would plug in here your integrating factor, this is your third step, okay, you would need to provide a final form which is y is equal to something here. Okay, that is after you have integrated this portion here. Your f of x is the item in this side, okay, your mu of x is your integrating factor. Once you can integrate that, you will have your result here, and you divide both sides by the same integrating factor, you will have here your final solution as a solution of your linear equation. Again, we will have examples for this and illustrating some examples specifically for integrating factors as well. But these are the general steps in solving linear equation. Again, standard form to make sure that it's really a linear equation. Next, find the integrating factor. And finally, for the third one, after this form here, solve for y, because that would be our intended function for the solution of our given first order differential equation, which can be converted into a linear equation. Thank you very much for watching.